Hey guys, so I wanted to start off with problem number 49 because I think in both classes we didn't get a chance to get all the way through number 49. So we'll do number 49 and then I'm going to start doing some of the example slides on friction, which we're going to focus on how to do friction problems tomorrow in class. I may also give you some more practice with these types like the Atwood machine with the tension and the two masses and the pulley system. So on number 49, the diagram in your book shows you that we have two different masses and they're connected by a string, and those are going through a pulley system. So I have 3.5 kilograms this way and then I have a mass of 8 kilograms on this side. And in part A, they're asking me to find the acceleration. So I need to find my acceleration. And first of all, I want to think about just in general, which direction. I know that these blocks will be accelerating, but I need to figure out too which direction that they will be accelerating. So this one's my 8 kilograms, this one's my 3.5. So it should make sense that the 8 kilogram block is going to move down the incline because it's the heavier mass. So this one should be accelerating in that direction, this one should be accelerating in that direction. Okay, and that's because this one is a larger mass, so it should be pulling, it should be moving down, pulling that 3.5 kilogram block up. These are connected also by the same string, so that means that if I find tension over here for this 3.5 kilogram block, it's the same thing over here on this 8 kilogram block because they're sharing that cable. So that cable, that string, I just have that one tension there, so I can think about that as well. Now, I broke this up into objects, and for an Atwood's machine, you're going to have to break it up into thinking about them as two separate objects. So I first just want to think about this 3.5 kilogram mass first. So we have, we'll just say for 3.50 kilogram object. I know if I need to find the acceleration, I know that I should probably draw first a free body diagram, right? So I want to think about all the forces that are acting on this 3.50 kilogram object. So I would have weight force, which is straight down. I have the normal force, which would be at some angle. And then I have my tension. Okay, so normal, tension, weight. I will show my axes slightly slanted, and I'm going to that makes my weight force broken into components. So I know that my angle is at 35 degrees, so angle 35 degrees right here. Okay? Now, if I'm thinking about acceleration, I know that the tension would be, here's my x-axis along here. So if that is which direction then my block, that 3.5 kilogram object is moving, then I need to find the acceleration in the x direction, which means I need to think about the forces that are acting in the x direction. So I want to write the sum of the forces in the x direction would be the tension. And then I also have my weight component in that x direction. So if my angle was right here, then that would be my weight. We know weight is equal to mass times acceleration due to gravity, mg. So that would be mg, and then in this case it would be sine 35. So that would be minus mg sine 35. Okay, well I know that this is accelerating. It is not at equilibrium. So it's not at rest, and I know that it's also not moving at constant velocity. So because I know those two things, I know that my force would be equal to the mass times acceleration equals tension minus mg sine 35. Okay, so what I don't know, I'm trying to find acceleration, but I also don't know tension. I know the mass of the object is 3.5 kilograms, and that helps me here and here. I know acceleration due to gravity but I don't know this and I don't know this. I could do the exact same kind of problem here for my 8 kilogram object because I know that they share the same tension. So let's solve this for tension. If I wanted to solve this for tension, I would get tension equals we're going to call this object 1. Mass of object 1, which is 3.5 kilograms, times acceleration in that x direction, plus mg sine 35. So this gives me tension for my 3.5 kilogram object. I want to do the exact same thing, but for my 8 kilogram object. Okay, so just move that up here. Okay, for the 8 kilogram object, we'll just call that M2. I know I have pretty much the same free body diagram, but it's now just shifted over towards this direction now. So looks the same thing, looks the same. It's just that now I know that my acceleration would be directed downwards. So if I wanted to write, and I know it's still accelerating just in that x direction. So the sum of the forces in the x direction, if it's accelerating this way, then I'm thinking about downward as being positive, and then anything that would be directed upward would be negative. So technically then, my weight force would be mg sine 35, and let's say m2, because this would be for our 8 kilogram, and we called that mass number 2. So mg sine 35 minus tension, because if our acceleration is directed downward, then it's going to be weight minus the tension, because tension would be moving in that opposite direction from acceleration. And we know that this is accelerating, so this would be the mass of that second block, which is 8, times its acceleration in the x direction, equals mg2 sine 35 minus t. Okay, well now I just want to have this equal to t. So let's do that as well. If I do that, I would get tension equals m2, I don't know why I put that 2 there, m2g sine 35, and then that would be minus m2 times ax. Well, I know that tension, if I'm thinking about the second mass, equals this one, and I know that tension, if I'm thinking about the first mass, equals this one. And the tension in both of these that are attached to both of these blocks